Good morning. Today we're talking about integer exponents. More specifically, we're talking about negative integer exponents. Before we get started, I want to remind you that what reciprocals are. The reciprocal of 4 over 5 is 5 over 4. The reciprocal of 1/3 is 3 over 1, which is 3. The reciprocal of negative 5 is 1 over negative 5. So when an exponent is a negative number, again, when the exponent is a negative number, like x to the negative 4th, we can think of it as taking the reciprocal. So in other words, this is really the same as this. So x to the negative 4 is equal to 1 over x to the positive 4. So it's taking the reciprocal. I want to highlight this because I think that this is a pretty important concept that you're going to be working with quite a bit today. Another way to visualize this is if we say the base to a negative exponent, it's 1 over the base to a positive exponent. Or we could say the base to a positive exponent is equal to 1 over the base to a negative exponent. So we don't want typically to leave negative exponents in our answer. Usually we want them to be positive. Not always, but very often. Most of the time we would prefer to have positive exponents. So how could we rewrite each of these so that we have only positive exponents? Well, this right here is the same as 1 over, okay, a base to a negative exponent is the same as 1 over that same base to the positive version of that exponent. And this one right here, we have a base to a negative exponent that's 1 over the base to a positive exponent. And this one right here, we have a base to a negative exponent, and that's the same as 1 over the base to a positive exponent. And this one right here, I want you to do that yourself. Hopefully what you end up with is 1 over n to the 3rd. So that was a lot of repeated practice with what it means when we have negative exponents. So how are we going to use that to simplify these problems? Well, this right here is the same as 1 over 8 to the 1st. And what we learned yesterday, or excuse me, that would have been last week, Friday, is that this is the same as 1 over 8. Whereas this one, that right there, is going to be 1 over 10 to the 4th. Now, if you take the time to calculate that, and some of you will remember what this is from things you did in middle school, this is 1 over 1 and 4 zeros, or 1 over 10,000. This one right here, 7 to the negative 2 power. That's 1 over 7 to the 2nd power. And 7 to the 2nd power is 49. Now this right here is 1 over 2 to the 3rd power. And that's 1 over 8. Again, that's because right here, this is a single 8. This is 10 multiplied by itself 4 times. This is 7 times 7, and this is 2 times 2 times 2, which is 8. So these are the final answers for those. And the difference in the directions for these is really important. For this one, they asked you to rewrite each one of these so that it has a positive exponent. For this, you have to evaluate them, but leave your answer in fraction form, but no exponents. And that's why there's a difference in the way that these look. Now for this, we're going to make use of some of the laws of exponents that we worked with last week. There's a couple different ways. Well, no, let's not do it a couple different ways. In this case, this is a power to a power. And what we learned is that x to the n raised to the m is equal to x to the n times m. So we have a power to a power. So this right here is the same as 6 to the 3 times negative 2. Well, what is 3 times negative 2? Well, 3 times negative 2 is going to give you negative 6. Ooh, you know what? Right now I want to go back and reread the directions. Using the law of exponents, simplify the following problems. Leave your solution as a value raised to a power and be sure to use a positive exponent. So we're going to have a value raised to a power and it's got to have a positive exponent. We have a value raised to a power, but we need that to be a positive exponent. So that's 1 over 6 to the 6th power. There's our final answer for that. This one right here, what we learned last week is that when you have a base divided, bases that are divided, what do we do with those exponents? It looked like this. That's x to the m minus n. When we're dividing like bases, we subtract the exponents. So this is 5 to the negative 4 minus 3. So that is 5 to the negative 7. And that is 1 over 5 to the 7th. 1 over 5 to the 7th. And we aren't going to go any further because they ask us to leave that as a value raised to a power with positive exponents only. Let's see what we have on this next page. Okay, this one right here makes use of the rule that we learned last week that says when you have like bases that are multiplied, x to the m times x to the n, we would add those exponents. So this right here would be a to the 1 plus negative 6. So that's a to the negative 5th. You might remember the directions for this said that we can't have any negative exponents. So that has to be 1 over a to the positive 5. And this one right here, remember, last week, I'm going to drive you nuts by talking about these so much. When we do a power to a power, we multiply those exponents. So this first thing we want to do is negative 3 multiplied by 7. And negative 3 times 7 is negative 21. And that is 1 over c to the 21st power. For this one right here, the top is, problem is going to make use of this rule right here. So that's going to be 3 to the 1 plus 2 over 3 to the 5th, which is 3 to the 3rd over 3 to the 5th. And that is now division. That goes back to what we had on the previous page. I wrote it right there. Dividing like bases, we subtract the exponents. So here we are going to subtract the exponents. 3 minus 5 is negative 2, but that's not okay because it said on the previous page that we wanted this to be written with a positive exponent. Okay, now this one right here. Okay, here we're dividing first and then we're going to multiply. So this right here gives us 4 to the, when we divide like bases, we subtract the exponents. Oh, remember when I told you about this right here? That means that that's 4 plus 8. So that's 4 to the 12th times 4 to the negative 14th. And that is, let's see, that goes back to this right here. When we're multiplying like bases, we add the exponents. That's 4 to the 12th plus negative 14th, which is 4 to the negative 2. And that is 1 over 4 to the second power, which would be 1 over 16 if they hadn't asked us in the directions to leave that as a power, a number raised to a power, a base raised to a power. Now here, we have to label these as true or false, but we have to show some thinking. So I think what we're going to do is show our thinking first. When I'm looking at this right here makes use of our adding of the bases. This is a like base times a like base, so we're going to add those exponents. So this is z to the negative 7 plus 2, and this side is z to the 7 plus negative 2. So we want to know if this is true or false, so I put the question mark there. This is z to the negative 5th, and this is z to the positive 5th. Those are not the same, because this is 1 over z to the 5th, which is not the same as z to the 5th. So this is false. Next, now we're dividing again. When we divide like bases, we subtract the exponents. So we want to know, does this equal? Let's see. A to the negative 8 minus 3. Negative 8 minus 3, that's negative 11. And this is, that's a to the negative 17 plus 6. And negative 17 plus 6, that's negative 11. And because those are equal, that is a true statement. This right here. When we are dividing with like bases, we are subtracting exponents. When we are raising a power to a power, we are multiplying exponents. So here we have 8 to the negative 8. And here we have, right, negative 6 minus 2 is negative 8. And here we have 8 to the negative 4 times negative 2 is 8. Those are not the same, so this is a false statement. And last but not least, right here, we want to use 2 rules on this side and 1 on that one. For this, there's a 1 here even though it's not written. So that is b to the 1 plus 4 over b to the 10th. And that's b to the 5th over b to the 10th. And now we would subtract these. This is b to the 5 minus 10, which is b to the negative 5. Okay, let me go through that one more time. Multiplying like bases means we add the exponents. And I just carry that down. Here I just did the 1 plus 4 and got the 5. When I divide like bases, I want to subtract the exponents. 5 minus 10 is negative 5. Now I'm going to deal with the right-hand side of this equation. When I have a power to a power, that is b to the 5 times negative 1. 5 times negative 1 is b to the negative 5th. And lo and behold, look what we have. If we wrote those with positive exponents, they would look like this, but they're still the same thing. So this is a true statement. So, what is your homework for tonight? Tonight, you need to complete this page. Just this one. I know we have another page after that, but that's our next lesson. That's what we will work on tomorrow. Square roots and cube roots. Today, we're just doing integer exponents. Be careful. Remember those rules from last Friday. I'm going to write them up here just for grins and giggles. You had a to the m times a to the n, and that's a to the m plus n. A to the m over a to the n, that's a to the m minus n. And last but not least was a to the m to the n, and that's a to the m times n. That's a review of what you did last Friday. And then today, what was most important is that when you have a to a negative exponent, it's 1 over a to the positive exponent. And don't forget this. Here's another. This is free. That equals 1. A to the 0 power is equal to 1. Good luck. It's 11 problems, and I will see you tomorrow.